Hello and welcome back to another video of IGCSE. In this video, we discussed all about momentum that you need to study for IGCSE, including the definition, conservation of momentum, and so on. After that, we even solved some past paper question that was for 2024. Let's get right into it. Alright, so first of all, what is the meaning of momentum? Imagine that there are two cars. This is car 1 and this is car 2, okay? Both of them have the same mass, so they have the same size, but one of them is moving at 100 meter per second, and the other car is moving really slowly. It's only moving at 5 meter per second. Try to imagine which car is easy to stop, the one that's moving at 100 or the one at 5. It's obviously going to be the car that's moving at 5 meter per second. So that means this car, the one that's moving at 100 meter per second, has more momentum. It has more motion. Now, so we can say its momentum is the quantity of motion of a moving body. But does this just depend on speed? Actually, no, it also depends on the mass. Let's say there are two trucks or two objects. One of them has the mass of 6,000 kg and the other one has 60 kg. Both of them are moving at, let's say, 100 meter per second. Which one can we stop easily? Of course, it's going to be 60 kg. Because of that, this means that 60 kg has less momentum. You can stop it easily. It has less momentum. So we can conclude that momentum is the quantity of motion of a moving body measured as a product of mass and velocity. Both mass and velocity are needed to find a momentum. Therefore, if we have to define it, we can say momentum equals to mass multiplied by velocity. If you write it as simple, it's going to be P equals M multiplied by V. Let's write down the units. We can say mass is going to be kilogram times V, velocity is ms minus 1 meter per second. So the units are going to be kilogram meter per second. Another unit for momentum is also Newton second. We can use any of these units. Now, momentum is going to be a vector quantity. Why is momentum a vector quantity? Because if you look at the equation, it is the product of a scalar quantity, mass is scalar, multiplied by the product of a vector quantity, velocity. So because we have a vector quantity, momentum also is a vector quantity. The direction of momentum is going to be same as the direction of velocity. Let's have a look at this example. A car has mass 600 kilograms, which is moving at 10 meter per second. Calculate its momentum. Formula for momentum is going to be mass times velocity. So this is going to be 600 times 10, and we get 6,000 kilogram meter per second. That's momentum. Now, calculate the momentum of a 5 kilogram box resting on a block. Now we know momentum is the quantity of motion. If it's resting, it has no momentum, so momentum is just 0. If you want to show it as calculation, we can write this as 5 multiplied by 0. No matter how much the mass is, speed is 0, momentum is also 0. Okay, now we will discuss a very important concept in momentum, which is called as the principle of conservation of momentum. To understand that, let's understand by an example. Okay, so we're saying we have an object A that has mass of 0.8 kilogram, which is traveling at 3 meter per second. It collides head-on with a stationary object B that has twice the size of object A. After colliding, both objects stick together and move right with a velocity of 1 meter per second. Compare momentum before and after collision. So for now, we'll just have to find momentum before and after collision. So as we can see, this is the situation. We have object A, this is object B. Let's write down the mass and velocity for object A and B. So they're saying it's 0.8 kg traveling at 3 meter per second. That's for object A. Object B, on the other hand, has twice the size, so it's going to be 0.8 times 2. So this will be 1.6 kilogram, and the velocity is 0 because it's a stationary object, right? So it's 0 meter per second. Now they're saying after the collision, they both stick together and move with a velocity of 1 meter per second. So the velocity is 1. But what about the mass? Now they're sticking together, so their mass is going to be combined. This is going to be 2.4 kilogram. Now we have to find out the momentum. So momentum of A and B. A is going to be ma I will write UA. U means initial velocity, so this is initial velocity plus MB UB. So M is going to be 0.8 multiplied by 3 plus 0. We get 2.4 kilogram meter per second. So that's our momentum before collision. Okay, now let's find out the momentum after collision. This is going to be mass of A and B multiplied by the velocity. B is now the final velocity, so it's going to be 2.4 times 1, and we get 2.4 kilogram meter per second. So now if you notice one thing, both of the momentum are equal. This is not a coincidence. This is the law of conservation of momentum. Momentum before a collision equals to momentum after a collision in a closed system. Okay, before collision and after collision the momentum is same. It's not lost unless there is an external force acting. External force, for example, if there was a second force that was pushing it, that would increase the speed, right? And the momentum would increase. But if there's no external force, it's a closed system, momentum before and after collision are going to be equal, and this is the principle of conservation of momentum. So let's do one example. We're saying that there's a car of mass 500 kilogram is traveling at 100 meter per second. It collides with another car of mass 650 kg traveling at 150 meter per second. Then they have a collision. After the collision, the first car is now moving at 20 meter per second. Of course, the mass remains same, right? The velocity has changed. While for the second car, we don't know the speed. We have to find the speed. Okay, what is the mass? Mass is 650 kg. They're saying calculate the velocity of second car using the principle of conservation of momentum. And we know the principle of conservation of momentum says momentum before collision equals to momentum after collision. Okay, so this is going to be MA UA plus MB UB. Momentum of A plus momentum of B equals to momentum of A after collision plus momentum of B after collision. So let's plug in our values. It's going to be 500 multiplied by 100 plus 650 times 150. This equals to 500 times 20 plus 650. This is B, okay? VB plus 650 times VB. We added them and we got a 147,500, and we move this one here, it becomes minus. This equals to 650B, so we'll subtract them and we get 137,500 whole divided by 650. This equals to VB, which equals to 211.5 meter per second. So this means after the collision occurred, object B was moving at 211.5 meter per second. This is how we can find speed using the conservation of momentum. But in reality, all of it is not conserved. Why? Because some of this is lost as sound energy, some is lost as internal energy, heat energy, when the objects become hot. But in theory, momentum before collision, all of the momentum before collision is transferred to all the momentum after the collision. Now let's try to find out the relationship between force and momentum. Okay, assume that we have an object which has a mass. Its speed is increasing from u to v. If you know the equation for acceleration, acceleration is final velocity minus initial velocity divided by time. Okay, we will relate another equation of force here. Force of an object equals to mass multiplied by acceleration. Let's add equation 1 in equation 2. So F is going to be m, and A equals to v minus u divided by t, right? Let's try to simplify this. So this is going to be m v minus u divided by t. So if we can write this as F equals to mv minus mu, we expanded it, divided by t. So we got mv minus mu divided by t. This means force is going to be in a final momentum minus initial momentum over time. So we can say divided by time. So resultant force is the rate of change of momentum. That means with time, what is the change of momentum? Now, we can, using this equation, we can understand why we have safety measures in car. For example, we have seat belts, we have airbags, and more. Now, in case of an accident, the change in momentum is going to be same. For example, there was this car, it was moving at 100 meter per second. It had an accident, and now this car stopped and it reached 0 meter per second. What is the change in momentum? We can write change in momentum as delta p as well, because delta means change and p means momentum. What is the change in momentum? It's 100 minus 0. So that is constant. Whether you have seat belts, airbags or not, the momentum will be same. But what we are changing is we're going to change the time. Okay, so we can say F is directly proportional to 1 divided by time. Force and time, when momentum is same, force and time are inversely proportional. That means if we have more time, we'll have less force. Less force is going to be experienced by the passengers, and there's going to be less chance of injury. That is why, for example, in a car, if the driver is wearing seatbelt but the passenger is not wearing seatbelt, the driver will face less chance of injury, because the time for him to experience the change in momentum was a lot less than the person who is not wearing seatbelts. This is the physics behind using these safety measures in cars. Now, what is impulse? So we all know that force can do a lot of things. It can change the motion of an object. It can change the size. It can change the direction. We can twist or push or pull. But let's focus on the object's motion. Force can change the object's motion. How much or the motion will change? It depends on two factors. It depends on the size of force. If the force is greater, the change in motion will be greater. On the other hand, it also depends on the time for which force acts. If force acts for a greater time, the change in motion will be greater. So based on that, let's write down the equation of impulse. We will use this equation for impulse as well. So we know F equals to mv minus mu into t. So impulse is basically force multiplied by time equals to mv minus mu. This force times time represent the impulse. So if you're ever asked to find impulse, you can just find impulse as force times time, but sometimes you can also find it by the change in momentum. So impulse is also change in momentum. Let's do an example now. This example compares forces experienced by passengers during an accident with and without airbags. Okay, so we have to find this force, force with and without airbag. What's the difference? When a car traveling at 15 meters per second crashes at the wall, 70-kilogram dummy comes to a stop after 0.03 seconds. On the other hand, when the airbag is attached, the dummy takes 5 times more time. Can you try to do these first? And then we'll compare the answers together. Alright, let's try to solve this. So the formula for force is going to be mv minus mu divided by time, based on this previous equation. Now, what is the mass? The mass is 70 kg times velocity is 15. This is final momentum minus 0, because we don't have any initial speed, it was at 0, at rest. Whole divided by time, this is going to be 0.03 seconds. If we calculate it, we'll get 35,000 newtons. On the other hand, let's calculate the force with the airbag. This is going to be, again, mass is same, 70 times 15. Momentum is same. Initial momentum is also same. Whole divided by 0.03 times 5, because it takes 5 times more time. If we calculate this, we'll get 7,000 Newton only. So you can see that when we did had airbag, the force was only 7,000 Newton, which the passenger experienced. On the other hand, when there was no airbag, it experienced a force as much of 35,000. This is a lot more. This is actually 5 times more. 5 times more force is experienced when there is no airbag. So if we can have safety measures that increase the time to come to a stop, we can reduce the signs of injury. Now let's do some past papers. This particular question is not from 2024. The questions after that is from the year 2024. Let's start with this. Figure 2.1 shows two railway trucks on a track. We have truck A and we have truck B. Truck A has mass 6,000 kg moving at 5 meters per second. It is approaching truck B of mass 5,000 kg, which is stationary. Calculate the momentum of truck A. So momentum is going to be mass times velocity. Mass of A is 6,000 multiplied by velocity is 5, so it's going to be 30,000 Newton second. B, the trucks collide, their buffers compress, and they bounce off each other. So there is a collision here. They collide and they bounce off each other, remaining undamaged. After the collision, truck B has a momentum of 27,000 kg per second. Determine the impulse applied to the truck B. So the formula for impulse is force times time, which also equals to change in momentum. What is the final momentum? It's 27,000 minus initial momentum, which was 0. It's going to be 27,000 Newton second. Now it says the trucks are in contact for 0.6 seconds. Determine or calculate the average force on truck B. So what is the formula for force? Force is going to be mv minus mu divided by time. So what is the change in momentum of truck B? It's going to be 27,000, like here, divided by time. Time here is 0.6 seconds. 45,000 Newton. It can also be written as 4.5 times 10 power 4 Newton, because 1, 2, 3, 4. Okay. Next, calculate the final speed of truck A. So since there was a collision, we can say that momentum before collision equals to momentum after collision. It's going to be ma ua plus mb ub. This is mass times initial velocity of A plus mass times initial velocity of truck B. This equals to mass of and final velocity of A plus mass and final velocity of B. Let's plug in our values. Truck B was stationary and the momentum of truck A was 30,000. all right, so here we'll write 30,000. Mass of truck A was 6,000 kg. VA, we need to find the velocity or speed of truck A, plus momentum of truck B after the collision. It's 27,000. So if you want to find VA, it's going to be 30,000 minus 27,000 divided by 6,000. This is the velocity of truck A, which equals to 0.5 meter per second. This is a question from 2024. Next question. Figure 2.1 shows a golfer about to hit a golf ball with a golf club. The initial momentum of the golf ball is 0. Define momentum. So momentum is the product of mass and velocity. The golf club is in contact with the ball for 5 times 10 power negative 4 seconds. The velocity of the golf ball as it leaves the golf club is 41 meters per second. The golf club has a mass of 0.046 kg. Calculate the impulse on the golf ball. Okay, so the formula for impulse equals to force multiplied by time. But since we don't have the force, we can also find the change in momentum, which is mv minus mu. So what is the mass? Mass is 0.046 multiplied by v. Velocity is here it's 41 minus 0.046 into 0. Why? Because it was stationary. It was initial momentum was 0. So if we multiply that, we get 1.9 Newton second. Calculate the force applied to the ball by the golf club. Force is going to be therefore impulse divided by time. This is going to be 1.9 divided by, this is the time, 5 times 10 power negative 4. This is going to be 3,800 Newton. Next question. A drag car is a racing car that is powered by a rocket engine. So this is a drag car. A drag car accelerates uniformly until it reaches the finishing line. Okay, so we have a graph here that shows that it's accelerating from here to the finishing line until the engine is then switched off and a parachute is open. The car decelerates until it's stopped. So speed is increasing until the finishing line. After that, it's decelerating until the car stops. The speed becomes 0. Figure 2.1 shows a car. The drag car has a mass of 1,400 kilograms. So that's an important point. Now, figure 2.2 is the speed time graph for the car during a race on a horizontal track. So the car is accelerating until finishing line and then it's decelerating until it stops. The car reaches its maximum speed of 130 meters per second. So we can say this is 130 at time of 6.5. So this would be 6.5. I just drew that roughly. This is just to mention the coordinates at the maximum point. Next, calculate the maximum momentum of the car during the race. So the formula for momentum is going to be mass times velocity. Mass is 1,400 as mentioned there. To find the maximum momentum, you need the maximum speed, which is 130. So if you multiply that, we get 1.8 multiplied by 10 power 5 Newton second or kilogram meter per second. State the feature of figure 2.2 that represents the distance traveled by the car. So this is a speed times graph. In a speed time graph, area under the graph represents the distance traveled. Determine the distance traveled by the car in the first 6.5 seconds. So we know distance equals area under the graph. Okay, so we can see that this is a triangle. The formula is therefore going to be half into base. Base is 6.5 times height is 130. And therefore the distance is going to be 420 meters. The parachute opens at 6.5 seconds and the car decelerates. Describe how in figure shows that the car is decelerating. So describe means you have to tell what is happening. How do we know the car is decelerating? Is because we have a negative line, negative slope. Here we had a positive slope. It was going up, therefore it was accelerating. Now the slope is coming down, so it's decelerating. Gradient is negative, or slope is negative. We will say gradient. Now, next question. The deceleration of the car is not constant. Okay. If you see, the line is curved. It's not a straight line. Therefore, deceleration is not constant. In the first half, we had a straight line. That is a constant acceleration. So we can say line is curved. Next, describe the energy transfer takes place as the car slows down. So at first it had kinetic energy because the car was moving. Kinetic energy is converted into internal or thermal energy. Figure 2.1 shows two identical trolleys, P and Q, held on a frictionless horizontal surface. A load is fixed to trolley P. So this is we have two trolleys P and Q. Trolley P has a load of 1.5 kilogram. This one. Now there is a compressed spring between trolley P and trolley Q. The trolleys are released. As the spring expands, it pushes the trolleys apart. They move in opposite direction. Trolley Q moves to right. Trolley Q will move there at a constant speed of 0.36 meter per second. The mass of each trolley is 1.2 kg. So the trolley itself, they weigh 1.2 kilogram. The mass of load on trolley P is 1.5 kg. The spring has negligible mass. Calculate the speed at which the trolley P moves to the left. So to do that, we need to follow the conservation of momentum, which says that momentum before equals to momentum after. This is going to be mass of trolley P times initial velocity of trolley P plus mass of trolley Q into initial velocity of trolley Q. This equals to mass of trolley P times final velocity of trolley P plus mq vq. Let's write down our values. Both of them were at rest, so we can say both of them were 0. Now let's find the momentum of trolley P first and then trolley Q. So what was the mass of trolley P? This was 1.5 plus 1.2, 2.7 kilogram. 2.7 kilogram. Now we need to take care of one thing. Velocity is a vector quantity. Here they told us that one trolley moved towards right, the other trolley moved towards left. Here it says that move to the left. So we have to consider one direction as positive and the other direction as negative. Let's just take, it's our choice. We can choose any one direction as positive and the other as negative. So I am choosing left as negative and right as positive. So this is going to be 2.7 multiplied by negative Vp plus mass of trolley Q, which is 1.2 times velocity of trolley Q. This is 0.36. If we move this part on the other side, it's going to be 2.7 Vp equals to 1.2 times 0.36. Therefore Vp is going to be 1.2 times 0.36 divided by 2.7. It's going to give us the speed of 0.16 meter per second. Now the kinetic energy of trolley Q when it moves at 0.36 meter per second. So the formula for kinetic energy is equals to half mv square. So half multiplied by the mass is 1.2 multiplied by 0.36 square. Kinetic energy is going to be 0.078 joules. Now state the energy transfer that takes place as the string expands. First of all, the string was compressed, so it has elastic energy from the compressed spring. Like this, as the string is expanding, the elastic energy is converting to kinetic energy of the trolleys. Now another question 2a. Define impulse. Impulse is force is a product of force and time. Figure 2.1 shows a rocket and exhaust gases. This is a rocket. These are exhaust gases. The exhaust gases are emitted from a rocket with a velocity of 1,400 meter per second and at a rate of 2,800 kilogram per second. Show that the force exerted on the rocket by the exhaust gases is 3,900 kilonewton. State the equation you use. To find the force, we can use this equation. Force equals mv minus mu divided by time. This can be written as mv minus u divided by time. Now, do we know the mass? We don't know the mass, but we can see that here it says that in the question they said that exhaust gases are emitted at a rate of 2,800 kilogram per second. So 2,800 kilogram in 1 second. So we can write this as 2,800 as kilogram divided by time, which is 1. What about velocity? Velocity is given. What about velocity? It's 1400 meter per second. So this is going to be 1400 minus 0 because it's starting from rest, from the ground. We get 3,920 Newton. To convert this into kilogram, small to big is going to be divided by 1,000. This will give us 3,900. This is approximately 3,900 kilonewton. Now, calculate the maximum mass that this force can lift from the ground. Ignore air resistance. So, force is going to be ma, but since this acceleration due to gravity, we can say F equals to mg. Force is the weight, okay? Mass is going to be F divided by g. F is 392,000 divided by g is 9.8, and this gives us 400,000 kilogram.